Firstly, we have to know about the 10 equations are there. There are 10 equations in glycolysis. 10 equations are sequenced by 10 enzymes. Means they are processed by 10 enzymes. So, firstly, before knowing about the complete cycle, we have to know about what are the things, what are the products formed in the glycolysis. Later onwards, enzymes. So, if we know the products and enzymes at a time, we can easily write down. Coming to a small review about this is, good girlfriend fills glass daily by 3 pegs or 2 pegs and plays ping pong. Coming to good means glucose. Girl, glucose 6-phosphate. Food, friend means fructose 6-phosphate. Fills fructose 1,6-bisphosphate. Glass, glyceraldehyde 3-phosphate. Daily, dihydroxide acetone phosphate and by 1,3-bisphosphoglycerate. 3 pegs means 3-phosphoglycerate, 2 pegs, 2-phosphoglycerate, place, pep means phosphoenol pyruvate. Coming to ping pong, pyruvate, the last product. So coming to glycolysis means it's just a breakdown of glucose. What is that, Nana? Breakdown of glucose. And this was done by means the scheme of glucose was given by Gustav Emden, Otto Meyerhoff, J. Parnas. Who are the three scientists? Scheme this, Nana? Gustav Emden, Otto Meyerhoff, J. Parnas. So, this was referred to as not only glycolysis but also known as EMP pathway. E means Emden, M means Meyerhoff, J means P means Parnas. So, we can call it as EMP pathway also. Okay, now? And this is the only respiratory process for anaerobic organism but not for the all organisms. It is the only respiratory process for anaerobic organisms. Only respiratory process for anaerobic organisms but not for all the organisms. We have to remember that. But it occurs in the cytoplasm of all the living cells. Okay, now? It occurs in the cytoplasm of all the cells and takes place in all the living organisms. Actually, glycolysis is for every organism. But only for respiration scheme means it's only to anaerobic organisms but not for all the living organisms. Coming to glycolysis occurs in all the organisms but not for the respiration process. It occurs in all the cells of all the organisms but only for anaerobic organisms. It is meant to respiration. Okay, now it is meant to respiration only anaerobic organisms for respiration. Okay, now but it occurs in all the cells of all living organisms of cytoplasm. That is special. What is the cytoplasm? So firstly, the breakdown of glucose gives glucose 6-phosphate. From glucose 6-phosphate we get glucose 6-phosphate. Glucose 6-phosphate to fructose 1,6-bisphosphate. Fructose 1,6-bisphosphate to glyceraldehyde 3-phosphate. Glyceraldehyde 3-phosphate to dihydroxy acetone phosphate. From dihydroxy acetone phosphate 1,3-bisphosphoglycerate. From 1,3-bisphosphoglycerate we get a 3-phosphoglycerate and 3-phosphoglycerate to 2-phosphoglycerate and pep means phosphoenol pyruvate and the last product is pyruvate. Here that is partial oxidation, Anna. We get 2 pyruvic acid molecules. Means the glucose is partially getting oxidized. Okay, now? The thing is, before we have seen about the products. What are the products in the reactions? But now in this pathway, we are going to see about the enzymes for the first step, second step, third step. Firstly, we know about the enzymes now. Hen paints path along the ground perfectly. People enjoyed path. So, she says to his father, hen paints path along the ground perfectly. People enjoyed path. So, they enjoyed it. Now, coming to hen means hexokinase. Paints means phosphoglycoisomerase. And path means phosphofructokinase. PFK also we can say. Along means aldolase. The means triphosphate isomerase. Ground means glyceraldehyde 3-phosphate dehydrogenase. Perfectly means phosphoglycerate kinase. People means phosphoglycerate mutase. Enzyme means enolase. And PA means pyruvate kinase, the last enzyme. So we have seen before, right, the products from glucose to fructose 6-phosphate like that. So coming to from glucose to glucose 6-phosphate, The enzyme which is ruling is hexokinase. From glucose 6-phosphate to fructose 6-phosphate, the enzyme is phosphoglucoisomerase or hexophosphate isomerase also you can write. After that, from fructose 6-phosphate to fructose 1,6-bisphosphatism, you can write phosphofructose kinase. Okay na? After that, fructose 1,6-bisphosphate to triose phosphate means you have to write aldolase. From triose phosphate to glyceraldehyde triphosphate, you have to write is triphosphate isomerase. And from glyceraldehyde triphosphate to DAP. Means here DAP means dihydroxyacetone phosphate we have said, right? To G3P to DAP we have to rule is the enzyme glyceraldehyde triphosphate dehydrogenase. Afterwards, either one we have to pick up in this pathway. Now we will take the glyceraldehyde triphosphate. From glyceraldehyde triphosphate to 1,3-bisphosphoglyceric acid, we get the enzyme is G3P dehydrogenase. Afterwards, again from G3P dehydrogenase, we will get 1,3-bisphosphoglyceric acid, right? From 1,3-bisphosphoglyceric acid to triose phosphate will get, and the enzyme is phosphoglycerate kinase. From 2 triose phosphate will get 3 phosphoglyceric acid will get 2 phosphoglycerate, and the enzyme is phosphoglyceromutase. From phosphoglyceraldehyde to phosphoglyceraldehyde we get PEP. So, and the enzyme is enolase. From PEP we will get a pyruvic acid, the enzyme is pyruvate kinase. Here the dehydration will be there. And we will use ADP and NADPH. Where we are synthesizing, where we are using it, we have to mention. So we have learned about the products and about the enzymes. Now we have to combine it, write them, and where we are using ADP, where we are using NADPH, and where we are removing the hydrogen molecules and where we are adding the hydrogen molecules. This 4 we have to mention here. While writing the pathway we will get. So we have studied about the products and enzymes. Now the whole pathway we gonna see. Okay now. So from glucose యొక్క breakdown which మనకి ఏమొస్తుందన్నా glucose 6-phosphate. Okay now, from glucose to glucose 6-phosphate they are using a hexokinase enzyme, and here we are utilizing ATP. We have to remember that we are utilizing ATP at the first process to give glucose from glucose 6-phosphate from glucose. Okay now, from glucose in the presence of hexokinase and utilizing ATP we are giving glucose 6-phosphate. And coming to second step, from glucose 6-phosphate we are getting fructose 6-phosphate in the presence of hexophosphorisomerase. What is that, Nana? Hexophosphate isomerase. Okay, and the equation will be like this: glucose 6-phosphate in the presence of hexophosphate isomerase gives fructose 6-phosphate. Okay now, afterwards the third step is from fructose 6-phosphate we are getting fructose 1,6-bisphosphate. Now the equation will be like this: fructose 6-phosphate in the presence of phosphofructokinase while utilizing ATP gives fructose 1,6-bisphosphate. Okay, after that the next step will be like this: fructose 1,6-bisphosphate gives G3P, means glyceraldehyde 3-phosphate. To write this, from fructose 1,6-bisphosphate in the presence of aldolase we are getting G3P, glyceraldehyde 3-phosphate. Glyceraldehyde 3-phosphate and DAP. DAP means dihydroxyacetone phosphate are isomers. So to convert the G3P to DAP, we have to use an enzyme isomerase. So we will continue with the G3P only, G3P only, glyceraldehyde 3-phosphate. From glyceraldehyde 3-phosphate we are getting 1,3-bisphosphoglyceric acid. Okay now. So now the equation will be like this: glyceraldehyde 3-phosphate in the presence of G3P dehydrogenase gives 1,3-bisphosphoglyceric acid. Now here we are using NADP and we are converting it into the energy rich compound NADPH plus H plus. Okay now, and next equation is 1,3-bisphosphate glycerolkinase glyceric acid gives 3 3-phosphoglyceric acid. Okay, now 1,3-bis-phosphoglyceric acid is giving you 3-phosphoglyceric acid in the presence of phosphoglycerokinase. Okay, now 1,3-bis-phosphoglyceric acid in the presence of phosphoglyceric kinase gives 3-phosphoglyceric acid. But here we are synthesizing ATP from ADP, and in organic phosphate we are synthesizing ATP. Afterwards, from 3-phosphoglyceric acid in the presence of phosphoglyceromutase, we are giving 2-phosphoglyceric acid. And after next equation is 2-phosphoglyceric acid is giving a pep-phosphoenol pyruvate, and the equation will be like this: from 2-phosphoglyceric acid in the presence of enolase and removing a molecule of hydrogen, means a molecule of water molecule, we are getting a phosphoenol pyruvate. And next step is from phosphoenol pyruvate in the presence of pyruvic kinase and synthesizing ATP, we are giving pyruvic acid. Here it is inorganic, means it's a partial oxidation. Okay, now what is that, Nana? It is a partial oxidation. It gives 2 pyruvic acid molecules. Afterwards, we have to look back about the pyruvic acid fate. What is the pyruvate fate? In the three type of oxidations are there: lactic fermentation, alcohol fermentation, and anaerobic respiration will be there. Okay, now so fermentation, these are of anaerobic respiration. Coming to aerobic respiration, we have to use Krebs cycle. So we will see about the pyruvic acid later.